Ariel is one of Uranus's largest moons and the only one we know of that has signs of past cryovolcanism, ice volcanoes. We don't see any active volcanoes here. So these must have stopped erupting long ago, right? Well, no. This is much stranger. In this image from NASA's Cassini spacecraft, look at how these smooth plains seem to radiate out from a central crater. You might think this is evidence of giant ancient eruptions, but it's actually much stranger than that. See, the thing about ice volcanoes is that they don't leave behind solid rock, like your typical volcano. Instead they spew out ice. And over time, this can carve big craters in the surface of the moon. But then, if there are repeated eruptions and the ice flows out to fill the crater, the result can look just like this. A bunch of smooth plains that radiate out from the center, and yet we can't actually confirm that Ariel used to have ice volcanoes. These features could have formed some other way. That's why I love exploring space. There are always more questions than answers. So what do we actually know about Ariel? Well, this is all we have. These images from the Voyager probes in the 80s and Cassini in the 2010s are the only close looks we've ever had at Ariel. And even these aren't that close. The resolution is pretty low. It's hard to tell anything about the surface, except the general shape of the moon. We don't even know how big the crater is that dominates the center of our view. The first thing you might notice about Ariel is its weird color. It's not quite white, but it's not really any other color either. I think it's just kind of dirty. See, this is pure ice. This is rock that's been covered by ice. And this is ice that's been sullied by space, radiation, and micrometeorites. Most of Ariel's surface is covered by ice, but there are patches where the ice seems to have worn away, revealing the darker material underneath. And when we zoom out, we can see that it's not just this patch of ice. Nearly the entire moon is covered by a thin shell of ice. It's not very thick. According to my measurements, it's probably only a few miles high. Scientists think that Ariel could have started out as a Kuiper belt object, something like a dwarf planet that got gravitationally tugged into Uranus's orbit and captured there. If that's true, it would explain why it's so icy. But hold on a minute, because something doesn't add up. For a small icy body, it sure has a lot of craters. You can literally count them: 1, 2, 3, 4, 5. There are at least 5 large craters on Ariel, and since it's so small, less than 600 miles across, it hasn't had enough time for most of these to be filled in by debris. That means they should be sharp and deep, but they're not. In fact, some of them look weirdly smooth. So if this isn't an ancient ice volcano, what could it be? One possibility is that the ice is wearing away. Over time, there's a lot of radiation around Uranus, and it can break molecules apart. When that happens to ice, it leaves behind gases and dust that can get blown away in space. Now, that can't explain why the bottom of the crater is flat. But it could be that it's been eroding for so long that it's actually worn down to a smooth shape. Or maybe there was a subsurface ocean. It's possible that Ariel has or had a liquid ocean beneath its frozen crust. And if there was a giant impact, it could have punched through both the crust and the ocean at once. If that happened, then the water could have boiled off into space, or frozen over to make a new icy crust. Either way, that would explain why there's no sharp rim. But that also raises another question. Where did the water go? Did it all boil away? Or is it hiding somewhere else? Well, remember how Ariel is only a few miles wide. That means it's pretty easy to completely circumnavigate it. That's not exactly what I wanted to hear, but hang on, there's more. Remember how I said that Ariel is only about 600 miles across? Well, according to NASA, it's actually 1,100 kilometers across, which is only 680 miles. Hold on, wait a second, 680 is bigger than 600. How is that not correct? See, the problem here is that we tend to use different units in different places. In the United States, we use miles and feet. In the UK and most of Europe, they use kilometers and meters. Now it turns out that the mile is about 1.6 kilometers long, but the kilometer isn't exactly 0.6 miles. It's slightly shorter. That means if you convert directly from miles to kilometers, you end up with a number that's a little bit too big. Scientists use the metric system, so they usually say that Ariel is 1100 kilometers across. But since we're here on Earth, let's use miles. Okay, back to our question. Where did all the water go? Well, take a look at this feature. Do you see anything strange? How about now? What about now? I'll give you a hint. It's not actually there. In reality, this is one single image overlaid on top of itself twice. In between those two views, there's a third view that shows us the missing piece. It's a weird dish-shaped crater. Here's why scientists think it's related to Ariel's past ocean. First of all, it's tall. It's about 2 miles high. Tall walls like this usually form when an object impacts at shallow angle. And look at how the pieces of the wall have slid down into the crater itself. That suggests that whatever broke through the ice and ocean wasn't a meteor. It was something internal, something that exploded outward, like a gas escaping from below the ice. When that happened, it didn't blow the whole moon apart, because the crust was probably only a few miles thick, but it did blow a hole into the ocean. And over billions of years, the water has slowly leaked out and drained away into space. That explains where the water went and why the bottom of the crater is so smooth. But it also raises a whole new question. What made the explosion? There's one obvious answer: heat. Maybe there was a hot ocean. Maybe it was heated by tidal flexing from Uranus's gravity. Or maybe it was warmed by radioactive elements deep inside Ariel. Whatever the source, it built up pressure until it was strong enough to rip through the ice. But then why doesn't Ariel have an active volcano today? I mean, you don't build up that much pressure without eventually erupting again. Well, it might. Remember, we haven't actually seen any active volcanoes here. All we've seen are the frozen remains of what might be ancient eruptions. And besides, just because a moon has volcanoes doesn't mean they're active. On Earth, we have plenty of dormant volcanoes. They've erupted in the past, but they're not erupting today. And on Mars, we see plenty of signs of past volcanism, but we don't see any active volcanoes. The same could be true of Ariel. Its volcanoes could have shut off long ago. How long ago? No way. We can estimate how long ago Ariel stopped being volcanically active by looking at the craters on the surface. See, every time an object gets hit by a meteor, it leaves behind a crater. Now, some of those craters will overlap each other, and it's impossible to tell them apart. But if we pick out the ones that look isolated, we can get a rough estimate of how old they are. The rule of thumb is that for an object like Ariel, there's one new crater for every 100 million years. So with about 5 craters, that means Ariel hasn't been hit by a meteor in about 500 million years. But that doesn't mean the volcanoes stopped working 500 million years ago. It just means that Ariel hasn't been hit by a big meteor recently. It could still be active. It just won't leave behind any solid evidence until it erupts again. At this point, we've ruled out the possibility that Ariel has active ice volcanoes. But there's still a chance that it has active cryovolcanoes. Maybe they just don't leave behind features we can detect from orbit. So while there's nothing in our data to suggest that Ariel is erupting today, that doesn't mean it's not happening. It's just one more thing that makes Ariel a truly strange and mysterious moon. I'm here. This video comes with a quiz that lets you check how much you remember. If you want more videos like this, subscribe to the channel.